Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2022, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. The bar chart shows the number of points scored by some quiz players. So we've got a bar chart here, haven't we? And on the side we've got the points scored, and along the bottom we've got the name of 5 people. How many points were scored by Ellis? So where's Ellis's bar? Ellis's bar is this one on the end, isn't it? You can see it's at a height of 16 then on there, isn't it? If you read across from the top of the bar to the axes, that's going to be 16. Okay, so 16 points. Part B says, how many more points were scored by Alex than Dan? So here's Alex's bar. You can see that it is here, this point then on the scale. Now the scale runs from 12 up to 16. That is a gap of 4, but we've only got 2 divisions in between. So each one of those divisions must be worth 2 then, mustn't it? So then that number in between has to be 14. And then we've got Dan down here. He is here on the scale between 8 and 12. So he must have got 10. Okay, so then the difference then in their scores, how many more points that Alex got than Dan, is going to be one of those numbers, take away the other. So 14 take away 10, that's equal to 4 then, isn't it? Okay, so he scored 4 more. Right, and then finally, Clara scored 13 points. Complete the bar chart to show this information. Okay, so where's 14 going to be? So I've got 12 there and 14 there. So 13 is going to be halfway between the top and bottom of that square then. It's going to kind of be in the middle. Okay, so I'm going to draw the height first at 13. I think it's going to go from there to there. And then I can then just draw the 2 sides of it then. Okay. Now I know that students love to fill these bars in. They always seem to do it for some reason, but it's not necessary. It's for aesthetic reasons. If you really want to fill your bar in, you can, but you won't get any extra marks for doing it. But if it makes you happy, why not? There we go. I'm going to fill mine now. Now I'm feeling happy. Question 2a. Write down each of the following. An even number between 11 and 17. Well, the numbers between 11 and 17 are 11, 12, 13, 14, 15, 16 and 17, of which you could choose 12. 12 is even, 14 is even, 16 is even. So any one of those 3 would be the correct answer. I'm going for 12. A square number between 15 and 35. Well, the square numbers start off 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So between 15 and 35, you've got a choice of 2, haven't you? Those two are between 15 and 35. So you can either have 16 or you can have 25. So either of those two answers are correct. The cube root of 64. So my cubes, I know 1 cubed is 1, 2 cubed is 8, 3 cubed, 3 times 3 times 3 is 27, 4 cubed is 64, isn't it? So the cube root of 64 is going to give me 4 again. Part B says 3 is a factor of 51. Find a factor of 51 between 10 and 20. So if I was finding the factors of 51, I've got 1 and 51. Neither of those between 10 and 20. 2 doesn't go. I know 3 does. 3 times what? 3 times 17? Oh, there we go. There's one between 10 and 20. So they kind of gave us that one half of it, didn't they? That factor pair. We just needed to find the other factor pair. So yeah, 17 will do. No point going any further. I've got the one that I'll need. 17. Question 3. Amit has 10 toy cars in a box. 4 are red, 3 are blue, 2 are white, 1 is black. Amit takes the toy car at random. Mark an arrow the probability that the toy car is red. Well, the probability that it's red is going to be the number of red cars, of which there are 4. So that's the number that goes on the top, successful outcomes. And then the number on the bottom is going to be total outcomes. And we know there are 10 toy cars. So there is 1 in 10 things that could be happening when you pick a car out of the box. So the probability is 4 out of 10. Now on this scale, I've got a scale running between 0 and 1. There are 10 divisions, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there are 10 divisions, so each one of those is worth 0.1. Okay? Now 4 tenths is 0.4, so 0.1, 0.2, 0.3, 0.4. It's going to be there, isn't it? So my arrow should go here. Okay? What's the probability that the car is green? Well, I don't remember there being any green cars. So the probability then of getting a green one is going to be the 0 green cars out of a total of 10, or 0. Okay, so that's quite an easy one. Just goes there on the end there. It's impossible, isn't it? Can't get a green one if there are no green cars in the box. 0. Question 4. Point A is shown on this grid. Write down the coordinates of point A. Okay, so coordinates go along the corridor, up the stairs, don't they? So along the corridor, 1, 2, 3, 4 jumps. That means that my x coordinate is 4. Up the stairs, 0 jumps is going to be 4, 0. B says plot the point B on the grid 3, minus 3. Okay, so we're going to go 3 to the right and minus 3 up. 3 to the right, boink, boink, boink. Minus 3 up, because that's actually 3 down, isn't it? So 1, 2, 3. So my point is going to end up being here. This is the point B. Okay, let's get rid of my workings. So yes, there's my point B down there. 3 minus 3. 5a, the diagram shows a parallelogram. The parallelogram has rotation symmetry of order 2. Mark the center of rotation with a cross, X. Okay, well I can see where it's basically the middle of the shape, isn't it? That's where we need to go. So if I was to mark the center, I can do it by sight really, that it goes there. Okay. If you're struggling to see it, you could find it by joining the diagonals of the shape together, because they would cross kind of in the center of the diagram. So if you were struggling to see it, you could kind of draw that on and that on, and you could see that those two lines pass through that central point there. Okay, so that'd be a different way of finding it. But anyway, it's that point there in the middle. That's where my X needs to go. Part B says, on the grid below, draw a 4-sided shape that has rotation symmetry of order 4. So if it's got order 4, it needs to look the same in 4 ways up. Now the only shape I can think of off the top of my head that does that is a square. So 4 corners of my square, 1 there, 1 there, 1 there, 1 there. There's my square. Let's just join it up. Okay, so square. And then obviously the center of rotation is going to be there in the center of my square. Question 6, use one of the symbols less than, equal to, or greater than to make each statement true. Is 0.8 less than, equal to, or greater than 4/5? Well, in order to answer that question, it's probably the easiest thing to do is rewrite 4/5 as a decimal, isn't it? Now, if I want to change a fraction to a decimal, you could just type it in on your calculator, 4/5 equals, and then change it to a decimal number. Or if you don't have a calculator, just change the base to like a power of 10, like 10, 100, or 1,000 by multiplying through by 2. That's 8/10 or 0.8, isn't it? Okay, so these two things are equal to each other. 4 squared is 16. Is 16 greater than, equal to, or less than 9? It's greater than, isn't it? So it's going to go that way around. Question 17. Morgan makes 15 cakes. Each cake needs a piece of ribbon 18 centimeters long for decoration. Yeah, bows are important. Ribbon is only sold in rolls of 1.2 meters, which can then be cut into 18 centimeter pieces. One roll of ribbon costs 92p. Calculate the cost of ribbon that Morgan must buy to decorate the 15 cakes. You must show your working. So we know that each piece of ribbon needs to be 18 centimeters long, and we know it comes in stretches of 1.2 meters, which in centimeters, remember, you have to times that by 100, don't you? That's going to be 120 centimeters, okay? Right, so then to work out how many ribbons we can get from each roll of ribbon, we're going to have to do some division, aren't they? So number of ribbons from each roll, that's going to be 120 centimeters, which is the length of the ribbons that you buy, divided by 18, because I need 18 centimeters for each ribbon. So 18 is into 120. Now that's 6.6 reoccurring, or 6 2/3. Just going to write down 6 2/3. Okay. Now 2/3 of a ribbon is not going to help us here, is it? Okay. It's going to have to be 6. We're going to have that little extra bit of ribbon that you have on the end is not going to be of any use to us, because we need 18 centimeter ribbons, and we can't have one which is 2/3 of that, 12 centimeters long. It's not going to be long enough. Okay, so that is wastage. You can't then tie that together with another piece, it'll look fugly. So yeah, we're just going to throw that little bit away. Okay, so that each roll then has got enough ribbon for 6 cakes then. Okay, so number of rolls required . Okay, so we used that one and that one there, didn't we? Okay, so the number of rolls required then, so we know now that we can get 6 bits of ribbon out of each roll, and we know that we require 15 altogether, because we've got 15 cakes. So how many rolls do we need? So if we take our 15 cakes and we divide it by the 6 ribbons per roll, then that is going to tell me how many rolls I need to purchase. Okay, so then 15 divided by 6, 15 divided by 6, 15 divided by 6, that comes out to be 2.5, doesn't it? Okay, now again, can't buy half a roll, so I'm going to have to buy 3 rolls, aren't I? Okay, so I can't buy half a roll from the shop, so I'm going to have to round up again and get 3 rolls of ribbon. So I know that 1 roll of ribbon costs 92p, and I know now that I require 3 rolls. So I can then work out the cost now, don't I? So the cost of ribbon is going to be the 3 rolls I require times the cost. We're just going to convert that into pence, 92 pence. Okay, so the 3 came from there. The 92p came from there. So I'm going to multiply those two together, and that's going to give me 3 times 0.92. That comes to £2.76. Okay, so that's how much you need to spend on ribbon. So that's £2.76, final answer. Question 8. Blake changes £450 into dollars. £1 is worth $1.34. Blake says 450 divided by $1.34 is 335.82. Therefore, 450 is worth $335.82. Is Blake correct or incorrect? Give a reason for your decision. Well, I think he's incorrect, isn't he? If he's got £450 and pounds are worth more than dollars, and they are because you can sell a pound for $1.34, then you're going to end up with more dollars than pounds after you do the exchange, aren't you? Not less. He's ended up with less dollars than he had pounds, and that can't be right. I think he's done the wrong thing here. He has divided when he should have times, shouldn't he? Okay, so the number of dollars he should have got is 450 times 1.34. So Blake is incorrect because he divided instead of multiplying. The correct amount is 450 times by 1.34, which is 450 times 1.34. That's $603. Okay, it's probably overkill. Probably don't need to work it out. Just to say that you would, if you divide instead of multiplied, is probably enough. But anyway, I've worked it out. Should have got $603. Question 9a. Simplify 5r minus 7t minus 3r plus 2t. Okay, so we've got a question here involving like terms. I've got terms in r and I've got terms in t. Now notice when I highlighted them, I highlighted the sign that went in front of them because the sign belongs to the term that follows. So 5r take away 3r, that's going to leave us with 2r, isn't it, from the yellow bits? Okay, and then I've got negative 7t plus 2t, or you can think of it as 2t take away 7t. Either way, you're going to get negative 5t. Okay, so we're going to write down minus 5t. So that's the bit that comes from the green bits. And then that's my final answer then. So 2r minus 5t. Okay. Right, next one. I've got a times a times a times a times a. That's 5 a's multiplied together. That's going to give me a to the power of 5. Okay. And then 5b divided by b. I think sometimes it looks easier if you do this as a quotient. So dividing that b into that b times to the power of 5, that's going to leave you with b to the power of 4, isn't it? Because another way to think about this, 7b to the power of 5 is 7 times b times b times b times b times b. And if you divide that by a b, then one of those cancels with one of those, and that leaves you with 7b to the power of 4 then, doesn't it? Okay, so that's my answer. 7b to the power of 4. Factorise 4a minus 12b. Now when you factorise, you're putting brackets back in, and then outside the bracket is the thing that they've got in common, and then inside the bracket you're going to have the things that they don't have in common. So 4a and 12b have got the number 4 in common, because 4 goes into 4a and 4 goes into 12b. So what they have in common is 4, that goes on the outside. And then what times 4 would give me 4a? That would be a. And then what times 4 would give me 12b? That would be 3b. So my final answer is 4 lots of a minus 3b. Okay. If you're not very good at these, you could just then double check, multiply it out again. Removing brackets seems to be a bit easier for people. So 4 times a is 4a, 4 times minus 3b is minus 12b. It does seem to work. Okay, that might be helpful for you. Anyway, let's move on. Question 10a. One morning, Harper records the first 50 vehicles to pass the school gate. Harper's results are shown in the table. So it's got types of vehicles. He's recorded cars, lorries, motorbikes, and vans, and the number that went past. Okay, so use Harper's results to estimate the probability that the next vehicle will not be a motorbike. Okay, so probability of not being a motorbike. Okay, what is that then? So how many not motorbikes are there? Well, cars are not motorbikes, lorries are not motorbikes, and vans are not motorbikes. So if you add all those together, 31 plus 3 plus 9, that is the number of not motorbikes, over a total of 50. You had 50 vehicles to pick from. Okay, so what's that then? So 31, 3 and 9, that adds up to 43. So the fraction is going to be 43 over 50 then, isn't it? Okay. Part B says, one afternoon, Reese records some vehicles that pass a school gate. 2/5 of the vehicles they record are cars. For Reese's results, write down the ratio of cars to not cars. Give your answer in the simplest form. Okay. Now, if 2/5 of the vehicle were cars, then 3/5, the remainder of a whole one, isn't it? If you think about it like a cake divided up into 5 pieces, if we're saying that 2/5 are cars, then the rest of them, 3/5 there, must be not cars, isn't it? Okay, so that is the ratio then of 2/5 to 3/5, and if I multiply both sides through by 5, you can see that that cancels down to 2 to 3 then. So for every 2 cars, there are 3 not cars. Question 11, write a number in each box to make this statement true. Something, take away 7, is -11. So if we've ended up at -11 and we've taken 7 away to get there, then we need to kind of reverse that and say, well, if I'm on -11 and I add 7, where does that take me? So calculate, if I'm on -11 and I add 7, you can see that takes me up to -4. So if I'm at -4 and I take away 7, I'm going to end up at -11. 3 over something divided by 2 is 3 over 10. Right, so we're dividing through by 2 over 1. And if you remember, fraction division, you can do keep, change, flip, can't you? So if I turn that over and write it that way, 3 somethings times 1/2 is 3 over 10. I think that must be a 5 there then. So the 5 times the 2 is going to give you the 10, and the 3 times the 1 gives you the 3, like that, doesn't it? Okay, so that should be a 5 there. Okay, and then something times 2/3 is 3/5. Okay. So I think we must have had, well, I guess it must be a 9 up here and a 10 down here. I kind of did this by inspection. I was thinking, well, if I divide what was here by 3 and I get 3, I must have had 3 to start with. Okay, and again, if I take this one here and I divide it by 2 and I get 5. Okay, so that's the kind of way that I did it, my thinking. If that's a little bit tricky for you, well, you could kind of move this to the other side. Times in by 2/3 on this side would be the same as dividing the other side by 2/3. So you could just type into your calculator 3/5 divided by 2/3. It's going to give you the same answer. It's going to give you 9 over 10. Okay, just flipping it around and use inverse operations. Okay, so either way, it's going to be a 9 and a 10 in there. Check it on your calculator, it should work out. Question 12, here are the first 4 terms of a sequence. It's going 7, 15, 23, 31. Write down the next term in the sequence. Okay, well, when I'm working out sequences, the first thing I look for is the common difference. What's it going up in here? So the difference between there, 7 and 15, that is 8. I have to add 8 to that, don't I, to go from 7 to 15. And it's the same here as well, isn't it? That's also add 8, and that's also add 8. Okay, so it's a +8 sequence. So if I then do the same thing, if I add another 8 on, that's going to take me to 39, then, isn't it? So the next term in the sequence is 39. Explain how you worked out your answer. I found the common difference was 8 and added this onto 31. Explain why 80 is not a term in this sequence. Okay, well, I can see already, what do these numbers all have in common? 7 is odd, 15 is odd, 23 is odd, 31 is odd. And each time I'm adding an even number, and an odd plus an even is always odd. Okay, so I can say all the numbers numbers in this sequence are odd, so 80 cannot be a term. Question 13. At the end of each day, a driver works out the mean distance they have driven so far that week. At the end of 5 days, the mean distance they have driven is 185.5 miles per day. At the end of 6 days, the mean distance they have driven is 190 miles per day. Work out how many miles the driver drove on the 6th day of that week. Well, you can use the fact that the mean is the total divided by the number of terms and work that backwards. So if a mean is equal to the total divided by the number of terms, so for the first one, the mean of 185, okay, that is equal to the total number of miles that we don't know divided by the number of terms that we do know, so that's 5, isn't it? Okay, so the only thing there that we don't know is the total. So if we rearrange that and we say that the total is the mean times the number of terms, so for 5 days, total miles travelled then is going to be the mean for the 5 days, 185.5, times by the number of days, which is 5. That comes out to be 185.5 times 5. That comes out to be 927.5 miles. Okay, so over the first 5 days he travelled 927.5 miles. For 6 days we can do the same thing. Total miles, that's going to be the average for the 6 days of 190 times the number of days, which is 6. So he would have done a total of 190 times 6. That comes out to be 1,140. Okay, so that means that the distance travelled on the 6th day must be the difference between those two numbers. Okay, so on 6th day it would have been 1140 minus 927.5. What does that come out to be? Right, so minus 927.5 must have been 212.5. 212.5. Okay, so that's the distance he travelled on the last day. Question 14. Box A contains 56 books. Box B contains 75 books. Ling has read 5/7 of the books in box A. Ling has also read the same number of books in box B. Work out the fractions of the books in box B that Ling has read. Give your answer as a fraction in its lowest terms. Okay. So first off, we need to work out how many books she's read from box A then, don't we? So box A, books read, we know she's read 5/7 of the books, and we know there are 56 books. So what we need to do is work out 5/7 of 56. Now, I know that 7 goes into 56 8 times, and I know that 5 times 8 is 40. So I think she's read, or he's read, I don't know whether Ling's male or female, or not either. But anyway, they've read 40 books. Okay, so then the fraction for box B, okay, so if the fraction of books read then is 40 over a total of 75, and we want to cancel that down then, so 40 over 75, we could just use the fraction key on a calculator, it's probably easiest. So 40 over 75, that's 8/15. Let the calculator take the strain there, 8/15. So that is in its lowest terms, and that's my answer then, 8 over 15. Question 15. A researcher asked 53 customers leaving a fish and chip shop what they have bought. The Venn diagram shows some of the results. So it's got 2 groups on here, fish and chips. How many customers bought chips and not fish? Well, that's going to be the people who are inside the chips area but outside the fish area. So it's going to be these in here then, isn't it? That's going to be 11. So how many customers? It was 11. Complete the Venn diagram to show the number of customers who did not buy fish or chips. Okay, so we know altogether there are 53 customers, but we've only got values for 11, 7 and 16 in there, and that doesn't add up to 53, does it? If you add those up, 16 plus 7 plus 11, that comes to, what's that, 27, 34? That adds up to 34. So there are missing 53 minus 34 customers, aren't there? So 53 minus 34, that has got a difference of 19. So there must have been 19 customers who bought neither fish nor chips, okay, from the fish and chip shop. What did they buy? I don't know, but I know it wasn't fish and chips. So that's that bit done. And then part C says one of the 53 customers is chosen at random. Write down the probability that this customer bought fish. Okay, so probability is successful outcomes over total outcomes. So the probability of him buying a fish is how many people bought fish, which is all the people in this group here. So it's going to be the 16 and the 7 added together, isn't it? So 16 plus 7 on the top over a total of 53 customers, so 53 altogether. So 16 plus 7, that is 23. So that I make that 23 out of 53 as the fraction there. Okay, 23/53. Question 16a, rearrange this formula to make D the subject. So I've got f equals 5d plus 4. Now these rearrangements work the same way as you would solve an equation, except you don't end up with a digit answer or a numerical answer. So if I take 4 away, I'm just going to try and get d by itself. So take 4 away from both sides. It will disappear on this side, and it will leave me with 5d on the right then, won't it? So I'm left with just 5d over here. But now on the left side, I've got f minus 4, okay? Now I say, if you were solving an equation, f would be a number, and you take 4 away and you get a smaller number. But when you're rearranging, it just gets to be a little bit more complicated on the left-hand side, okay? And then next, I'm going to divide both sides by 5, okay, because that will cancel with that and it will leave me with d. So I'll get d, and then I'm just going to get whatever it just written down, f minus 4 over 5. So that is the rearranged formula, that d is equal to f minus 4 all over 5, like that. Okay. Part B says use the formula v equals u plus at to find the final velocity when initial velocity is 5, the acceleration is 7.5, and time is 6. Okay, so this is the SUVAT formula that we need to know. So initial velocity is the u of this. This is the u value, so that's 5. A is acceleration. We know that a is equal to 7.5. And t is the time, isn't it? So 6 seconds is that one there. Okay, so v equals u plus at is 5 plus 7.5 times 6. Okay, so just need to type that into the calculator. 5 plus 7.5 times 6, that comes to 50. Okay, so that's equal to 50. Now what? 50 watts. Well, it's going to be in meters per second, isn't it? Because we've got meters, seconds, meters per second. So it's going to be meters per second, like that. So 50. Question 17. The density of gold is 19.3 grams per cubic centimetre. Sam has a gold nugget of volume 7.5 cubic centimetres. That's a lot of gold. Calculate the mass of the gold nugget. Okay, so we're going to be using the density, mass, volume triangle. Goes like that. Mass on the top and density and volume underneath. So with all these sort of triangles, you have to kind of work out the 3 things. Well, they always give you 2 of them and one of them will be missing. So here, what is the mass? Well, the mass is the thing that we're wanting to find, isn't it? That's the answer we're trying to find. So we don't know the mass right now. But we do know the density, though. Density is that one there, look, 19.3 grams per cubic centimetre. So 19.3 grams per cubic centimetre. And then the volume is 7.5 cubic centimetres. That goes there then. So the volume is 7.5 cubic centimeters. Okay, now you just need to check all your units are compatible. This is in cubic centimeters and so is this, so we're all good, it all matches up. Okay, so then covering up the thing on a find, mass, that tells you what to do with the other two. It's density times volume, isn't it? So mass equals density multiplied by volume, which is 19.3 times 7.5. What does that come to then? 19.3 times 7.5. And that comes to 144.75. That's my final answer. 144.75 grams. Question 2. In 2019, Comet A and Comet B were both seen from Earth. Comet A is seen from Earth every 84 years and Comet B is seen from Earth every 105 years. Find the next year when both comets will be seen from Earth. Now, this question is actually a lowest common multiple question because if you think about it, we just need to work out what's the lowest common multiple of 84 and 105, and then that will be the number of years that they will then take to be in the same to arrive at the same time again. So we could, in theory, just kind of start listing them out. So 84, 168, and so on. That might be one way to do it. But these numbers are large, and they're also quite far apart. So I've got a feeling it could be millennia before we actually meet these two comets in the same year again. So I'm going to use a different method. I'm going to be using prime factor decomposition to do this. So I'm going to first write these numbers both as a product of their prime factors. So on the calculator, so I'm going to be using the new Casio calculator in this paper. And on this particular model, to turn something into a product of its prime factors, you type in the number first, 84, and then you press equals. And then we're going to press the format key, and then we're going to go down to this one that says prime factor. And then that should write it as a product of its prime factors, which comes for 84 to be 2 squared times 3 times 7. Okay, going to do the same thing with 105. So 105, execute, and then I'm going to press the format key and go down to prime factors, and then that should tell me the answer. I get 3 times 5 times 7 for that one. So 105 is equal to 3 times 5 times 7. Okay, so then my LCM is going to be every base that appears. So I've got a 2 in that one, and the highest power of 2 that appears is 2. So it's every base that appears to the highest power that it appears. So I've got a 2 to the power of 2, that's the highest one. I've got a 3 in both, and the highest power of both is just 1. So I'm just going to have a single 3. I've got a 5 in 105, and that's power 1. So I'm going to have a single 5 in my LCM. And then finally, I've got a 7 and a 7, and the highest power of that in both is just 1. So I'm going to have a 7 in my answer too. Okay, so I'm going to get 2 squared times 3 times 5 times 7 as my answer. So what's that then? 2 times 2 times 3 times 5 times 7. That comes up to 420. Oh, it wasn't that far then. It wasn't millennia. It was 420 years. Perhaps it would have been quicker just to write them all out. I don't know. Anyway, I like that method. 420. So now we know the number of years it's going to take for this event to happen again. But just be careful here because it says find the next year when both comets are seen on Earth. We've just worked out that it's going to be 420 years later. But 420 years later than what? It's going to be 420 years later than 2019 then, isn't it? So then the year is going to be 2019, the year 2019 plus those 420 years. So what's that then? 2019 plus 420, that's 2,439. So 2439, you're going to have to wait a long time to see them occur at the same time again. So 2439. Question 19. Eve is counting the photos on her phone. The ratio of the numbers of photos of her family to the photos of her friends is 3 to 7. She has 450 photos of her family. 80% of the photos of her friends include Jack. Work out how many of the photos of her friends include Jack. Well, Jack's obviously a very special friend if he's in 80% of her photos, but let's work out the maths. So the ratio of the number of photos to the number of families is in the ratio of 3 to 7. Let's start with that. So let's start with this ratio. Fam to friends is in the ratio of 3 to 7. Okay, so just that's where we got those from. And then we know that 450 photos of the family, so that's on this side, isn't it? So family is this side, so this is 450. So how many friends photos are there? Well, if I wanted to scale up the ratio of 3 to 7 up to 450, I would have multiplied that up by 150, wouldn't I? 150 times 3 is 450. So I've increased that by a factor of 150. If you can do that maths in your head, you just do 450 divided by 3, it'll give you 150. Now, doing the same thing to the other side, timesing that by 150, that's going to tell me how many photos I've got of my friends. So 7 times 150, that comes to 1050. 1050. Okay? So, yeah, that came from there. So now we know we've got 1050 photos of friends. Okay, so we now know a number of photos of friends. Now we can find 8% of those photos, can't we? Okay, so if we're doing a percentage question, final, original, multiplier, what's the final, what's the original, what's the multiplier? Okay, well the final is what I want to find because I want to know how many photos I've got of Jack. The original is this number over here. This is the original. Okay, so I've got 1050 pictures altogether of friends. And the multiplier then is going to be this number up here then, isn't it? The multiplier is going to be 80% written as a decimal, which is 0.8 then as a decimal, isn't it? Okay, so that's my multiplier. So then the final is going to be, covering up the thing I want, F, that's O times the N, so it's the original times the multiplier. Okay, so that is going to be 1050 times 0.8 then. So how many have got Jack in there? 1050 times 0.8, that comes to 840 Jack photos. That's a lot of photos of Jack. Okay, so yeah, so work out how many photos of a friend include Jack. There are 840 of them. Question 20, Rowan invests £4,000 at a rate of 3.5% per year compound interest. Calculate the value of Rowan's investment after 5 years. Give your answer to the nearest penny. Okay, so this is another percentages question. So I'm going to use the triangle final original multiplier again, but because it's compound interest, I'm just going to add the number of years on the end because I need to know that as well. So final is the amount that we get at the end of the investment. So that is the thing that we're trying to calculate, isn't it? Okay, that's the final that we want to find. Now the original, that is the amount we started with. It's the investment, that's £4,000. Okay, now what's the multiplier? Now the interest rate is 3.5%. Okay, so that's added on to the original amount. So when you're doing, it's a percentage increase, this one essentially, isn't it? So we're going to start with 100%, and if we add on 3.5%, then we've got 103.5%, which as a decimal is 1.035. So that's my multiplier. Okay, 1.035. Okay, and then finally, number of years, that is 5 years, isn't it? Okay, so years is 5. Okay, so then using the triangle, cover up the thing I want to find. Final is original times multiplier. So final equals original times multiplier. Now this time I raise the multiplier to the number of years when we're doing compound interest, because you have to apply the multiplier several times over, 5 times over. Okay, so that's going to be 4,000 times 1.035 raised to the power of 5. Okay, just tap that into the calculator. 4,000 times 1.035 to the power of 5. Now I make that 4,750.74. I need to round it off to the nearest penny, so yeah, to That's going to round off to 7.5 then, isn't it? So that's going to be 4750.7 rounded up to 5. Okay, that's my final answer. Yeah, the value of the investments. Just double checking it isn't like the amount of interest added, because they sometimes do that. Yeah, it's £4,750.75. Question 21. The table below shows the approximate populations of 3 countries in 2020. So we've got China at 1.44 times 10 to the 9, Kiribati, which is 1.19 times 10 to the 5, and Tuvalu, which is 1.18 times 10 to the 4. Okay, so part A says calculate the approximate total population of Kiribati and Tuvalu in 2020. Give your answer in standard form, correct to 3 significant figures. Okay. So the total population of these 2 countries is going to be those 2 amounts added together, isn't it? So it's going to be total is equal to 1.19 times 10 to the 5 plus 1.18 times 10 to the 4. And I'm just going to use the exponent key on my calculator for typing in standard form. Okay, so I'm just going to type in the mantissa part, 1.19, and then I'm going to press the exponent key and type in the power. Okay, so 1.19 times 10 to the 5, and I'm going to add on the next number. So that is 1.18, type in the mantissa part, press the exponent key, type in the power. Okay, now my calculator is saying that is equal to 130,800. Okay, now clearly that is not in standard form, that's just a normal number. Depending on your calculator, you might do it in standard form or not, but mine didn't, so I'm going to have to convert that into standard form. 1.308 times 10 to the what? That's like 1, 2, 3, 4, 5 jumps. So it's going to be 1.308 times 10 to the power of 5. Now, given that correct to 3 significant figures, 1.31 times 10 to the 5. Okay, show that in 2020 the population of China was approximately 120,000 times the population of Tuvalu. Okay, so we're going to do some division there, aren't we? So what we're going to do is divide one by the other. So we need to show that 1.44 times 10 to the 9 divided by the Tuvalu number, which is 1.18 times 10 to the 4. What does that come out to be? So again, I'm just going to use the exponent key on my calculator to work that out. So China, 1.44 x times 10 button, and then type in the power of 9, and we're going to divide that by 1.18, the exponent key, and then the power of 4. Now mine comes out to be 122,034 to the nearest whole number. So that comes out to be 122,034, which is approximately 120,000. I think that will do. Okay, so I've found it exactly, and then I've rounded, well, kind of exactly to the nearest whole number anyway, and then I've rounded off to 2 significant figures, isn't it? So that's what it is, to 2 significant figures. So I've kind of shown it. I think that's good enough. Approximately, yeah, it's all good. Let's move on. Question 22. A theatre has an adult price and a child price for their shows. A group of 4 adults and 5 children paid a total of £136. A group of 3 adults and 2 children paid a total of £81. Work out the price of 1 adult and the price of 1 child. You must show your working. Now this might not look like it, but it's actually a problem involving simultaneous equations. But in order to solve it, you need to form those simultaneous equations first. So you notice that both sentences contain adults and they contain children. So I'm going to let the adults be the letter A and the children be the letter C, because that seems to be quite straightforward. Okay, and then I'm going to rewrite this as an equation then. So a group of 4 adults and 5 children paid a total of £136. So 4A plus 5C equals 136. Okay, so that's my first equation. Now my second equation, 3 adults and 2 children pay a total of £81. 3a plus 2c equals 81. So that is my second equation. Okay. Now, I want to solve these simultaneously, and in order to do that, we need to have the same number of each thing, okay, and so that we can eliminate one. So either we try and get the same number of children in both equations, or we get the same number of adults. Now, in this one, it doesn't seem to make much difference. It's going to be a little bit trickier either way. So I think I'm going to try and get the number of children on the basis that I like multiplying by 5s and 2s better than I like multiplying by 4s and 3s. So if I times this one by 2 and I times this one by 5, I'm going to get, just taking everything in that first equation and doubling it, I'm going to get 8a plus 10c is equal to 2 lots of 136, that's 272. And then taking everything in my second equation and timesing it by 5, that's going to give me 15a plus 10c, and that's equal to 5 lots of 81. What's that going to be? 405. Okay, so you can see now I've got the same number of children in both expressions. Okay, so that means I can take one away from the other. I'm just going to take the smaller one away from the bigger one, which is like the top one away from the bottom one. So if I had 15 adults and I took away 8 adults, that is leaving me with 7 adults, isn't it? Okay, so that's 7a. 10c take away 10c, that cancels, leave me with no c's. And then I've got 405. If I take away 272, what's that then? So 405 minus 272, that comes to 133. Okay, so I've got £133 for 7 adult tickets, and now I should be able to work out the price of one adult ticket just by dividing through by 133 divided by 7. So divide that by 7, that gives me 19. Okay, so the price of one adult ticket must be £19. Okay, so I've got half the answer. I need to go on and find the other. I'm going to substitute a is equal to 19 into one of my original equations. I think I'm going to go for the first one because I like multiplying by 4 more than I like multiplying by 3. So I'm going to say that into equation 1, that's going to give me 4 lots of 19 plus 5c is equal to 136. So what's 4 lots of 19? Double and double again. So that's 76. So 5c is going to be 136 minus 76. That is 60, isn't it? Okay, so if 5c is 60, then c is going to be 60 divided by 5. It's going to be 12. So the price of a child ticket is 12. Okay. Now at this point, you could just double check by tapping the numbers into the second equation, make sure it works out. So my check, if I sub in a is 19, c is 12 into the second equation, is 3 lots of 19 plus 2 lots of 12, is that equal to 81? I'm just going to check that on my calculator. So 3 times 19 plus 2 times 12, that does indeed come out to be 18, so I'm 81. So I'm happy with that. Works out. Okay, I think I've got it. So yeah, done. Question 3. An examination has 3 papers. Paper 1 is marked out of 60. Paper 2 is marked out of 40. Paper 3 is marked out of 100. The 3 marks are added together to form a total mark out of 200. A student scored 65% on paper 1 and 70 on paper 2. Find the mark they now need to get on paper 3 to achieve 64% of the total marks. You must show your working. Well, we need to work out what all these percentages we've got first to work out how many marks we got first on paper 1 and 2. Then we can work out how many marks we need on paper 3 then, don't we? Okay, so paper 1 is marked out of 60 and the student scored 65% of that. So what we need to do is work out 65% of 60. Now with percentages, I like to use this triangle, final, original, multiply to work out what to do with percentages. Now here, I want to work out the final mark because I know what the mark was, the paper was originally out of, and I know the percentage for each of these questions. I'm going to be finding the final for these. So covering up the final, that tells me that the final equals original times multiplier. Okay, so that's the calculation I'm going to be doing for each of these. I'm going to take the original one and multiplying it by the multiplier. So for paper 1, it was marked out of 60, so the original mark was 60. So 65% as a multiplier. You just need to divide it by 100 or just rewrite it as a decimal. It's pretty easy. It's 0.65. And then if you type that into a calculator, 60 times by 0.65, that comes to 39. So you scored 39 marks on the first paper. Okay, now paper 2 was marked out of 40, and we're told that he got 70% on that. So to work out the number of marks then, that's going to be the total marks, the original marks, times the multiplier of 0.7, and that's going to give me 40 times 0.7, that's 28 marks. Okay, now he wants to score 64% overall. Okay, now we know that the total marks out of everything is 200, so to achieve 64% of the total marks, he's going to need 200 times 64% written as a decimal. That's 0.64, and that comes to, I think it's 128, just off the top of my head. You can verify that on a calculator if you wish. So what has he got so far? He's got 39 and 28 so far, so 39 plus 28. That comes to 67. So he's got 67 marks already. Okay, now to get 64% overall, he needs 128 marks. So what's the difference then? So if I take away the 67, we should be able to work out the number of marks he still needs to get. So 128 minus 67, that comes to 61. Okay, so he's going to need to get 61 marks in paper 3 in order to bump up his amount to 64 overall. Question 5. B is 12 kilometers due east of A. C is southeast of A and on a bearing of 225 degrees from B. Complete the diagram to show the positions of A, B and C. Show clearly the values of all 3 angles in triangle ABC. The scale is 1 centimeter, represents 2 kilometers. Okay. And we've got the point A marked and a north line drawn. So we're going to have to use a protractor and a ruler to do all these measurements and make sure we draw our scale correctly. Okay, so first off, we know that B is 12 kilometers due east of A, and east is on a bearing of 90 degrees from north, isn't it? So if I mark with my protractor 90 degrees from the north line, then I know that B is going to be somewhere along this line. Okay, right, so how far exactly is it? Well, we know it's 12 kilometers and we've been given the scale of 1 centimeter represents 2 kilometers. So to draw 12 kilometers, we're going to have to say, well, that's 6 centimeters, isn't it? So carefully measuring along my ruler 6 centimeters and then stop in. That is going to be my point B. Okay. Right. So let's just mark B. Now, next up, point C, we're told is southeast of A on a bearing of 225 from B. Okay, so we've got measurements from A and from B, so we can maybe if we draw those 2 lines on, then C is going to be in the intersection. Okay. Before I do that, let's just have a think about what all these various angles are. So southeast, what's that as a bearing? Well, it's going to be 135 degrees, isn't it? Because if I draw the compass up, north, east, south, west, then north is on a bearing of 0, 0, 0, east is 0, 9, 0, south is 1, 8, 0, and west is 2, 7, 0. So southeast is going to be halfway between 90 and 180, so that's 135 degrees. Okay, so again, using my protractor to measure around from the north line 135 degrees, then I know my point C is going to have to be somewhere along this line. Okay, now I don't know exactly where yet, but I do know it's somewhere along this line. So let's just draw that on for now. Okay, I don't know how long the line needs to be, so let's just make it quite long. Next up, we've got to draw this bearing of 225 from B. So what direction is 225? Well, if you remember, south is 180 and west is 270. It's going to be kind of southwest, isn't it? Okay, but we need something to to draw from, we need a north line first on B, don't we? Okay, so reaching for a set square, if I put that on my line that I know is running east-west, then because the set square has got 90 degrees, I can just kind of draw off that. I can just quickly draw the north line off that line there. Okay, so that's my north line. So that's where I'm going to be measuring my bearing from. Okay, so I've got to go on a bearing of 225, but again, I've got a slight issue in that protractors only go up to 180. So a bearing of 225 is beyond the edge of the protractor. Okay, so what I'm going to do is I'm going to work out this inner angle here. So that's going to be 360 minus 225, isn't it? Which comes to, what's that? That's going to be 135, isn't it? Okay, so I'm going to measure back from the north line this time at an angle of 135. Right, remember I'm going to have to be using the inner track of the protractor this time because the out one starts on 180, the inner one starts on 0. So coming around to 135 and marking it there. Okay, then I know that my side, my C is going to be somewhere along this line too, then, isn't it? Okay, so it's going to be somewhere along this line on a bearing of 225. Right, so we can see that the two lines meet. That's going to have to be point C then, isn't it? Okay, now it says we also need to show clearly the values of the three angles. Now, the first two I can probably just calculate, can't I? Because I know I was going, AB is directly east, which is 90 degrees, and AC is on a bearing of, what was it? It was 135, so the difference between the two of them is just going to be 45 degrees. Okay? Similarly, if I think about that angle there, it's going to be the difference between 270 and 225, so that's also 45. So that means that angle down there must be a right angle then, isn't it? Because 45 plus 90 equals 180. I'm just going to double check, make sure it is actually 90 degrees. I think you can see there it's spot on, isn't it? So I'm pretty happy with that. Good, job done. Let's move on. Question 25. The diagram shows an isosceles triangle ABC. We're told that AB equals AC equals 19 centimeters and angle BAC is equal to 54. Calculate the length of BC. You must show your working. Okay. Now, this is a job for trigonometry because I've got sides and angles and I want another side. But at the moment, this is not a right angle triangle, so I can't immediately apply trigonometry. But if I get out my ruler and do this, I can divide my isosceles triangle into two matching right angle triangles. Okay, so if you do that, it's going to cut this line exactly in half. Okay, that's just a property of isosceles triangles. You can do this with any isosceles triangle. You can draw a line down from the tip of the isosceles triangle down to the base, and it's going to cut it into two right angle triangles like that. Okay, so we can just use one of these in our problem then. So let's just say then that's B, that's A, and let's call that M the midpoint of BC. Okay. Okay, then I know that's a right angle there. I know that's 19, and what I want to do is to find this side here, which I'm going to call, let's call it X, because we like to call things X when we're doing algebra, don't we? So let's call it X. So then, which side is which then? So if with trigonometry, what we need to do is label up our sides first, don't we? Okay, so which sides have I been given? Well, hold on, we haven't found the angle yet. What's this angle down here? Now, as well as cutting this side down here exactly in half, doing this also cuts that angle exactly in half there. So half of 54 is 27. So that angle there must be a 27 degree angle. Okay, so that's the angle up there. So this makes X the opposite, and it makes 19 the hypotenuse. Okay, and we want the opposite from the hypotenuse. So luckily we've got a handy mnemonic to help us work this out. SOHCAHTOA. Now, which one do we need? Now, sometimes it's easy to think about which ones we don't need. If that's the opposite and the hypotenuse, this is the adjacent. Now, we're not interested in the adjacent. We don't know it. We don't want to find it. So any of the ratios got a in it are not the ones we want. So that, by process of elimination, then the one we do want is that one there, the sine. Okay? So the sine of my angle, sine theta, is equal to op over hyp. Okay? Some people try and remember these without the angle placer in there, the theta in it, which is bad because then you don't know what to do with the angle when you get it. So sine theta equals op over hyp. Trying to remember it with the angle placeholder in the right place so you know where to stick the angle. And then sub in the things that we know. So theta is the angle up there, that's 27. So sine 27, and that's equal to the opposite. That is our unknown x, so that goes there. X over the hypotenuse. So the hypotenuse is the longest side, it's that 19 there. So subbing that in, 19. Okay, so x is the thing I want to find. Just rearranging this equation, kind of shimmying that up there. Look, I'm going to get x is equal to 19 sine 27. Now I can type that into the calculator. So just make sure your calculator is in degrees, 19 sine 27. Otherwise your answer will be wrong. That comes out to be 8.625 and change. We're going to round off to three significant figures. I'm just going to say that is equal to 8.63. Okay, to two decimal places. But remember, that's half the line we want. So if x is 8.63, we want BC, don't we? BC is going to be 2x then, because if that's x, then that's also x there. So we need to have two lots of this. I'm just going to use the full calculator display because it might round differently after I've done a calculation with it. That rounds off to 17.25. Okay, 17.25. Final answer, round to three significant figures. 17.3 I'm going to go for. All right, 17.3. Question 7, part A. Construct the perpendicular from the point P to the line AB. So you need a compass with a short pencil. Try and make sure the tip of the pencil and tip of the compass is in the same place. Make sure you've got a pencil which is small so you can kind of fully rotate your hand. Now the first thing I'm going to do is going to mark 2 points on the line AB which are equidistant from the point P. Okay, so I've made 2 marks, look, there and there. Now these are going to be so I can form the perpendicular bisector. So coming to the first mark, I'm going to draw an arc between the 2 lines, like that, all the way around. And I'm going to go and switch over to my second mark that I made. Not the arc I've just drawn, but the one before. And I'm going to draw a second arc like that. And you should see that these two meet in 2 places. One of them is a point P, and the other one is a point on the opposite side of the line. Okay, so putting my ruler carefully between those 2 points, I'm now able to draw the perpendicular bisector, or the line that is perpendicular from P to the line AB. Okay, so just drawing that on there. And you should be able to see that that is definitely a 90-degree angle. You can measure it if you like, but I'm pretty confident that's spot on. Right, job done. So the trick was to do those 2 marks first of all, wasn't it? Because I needed 2 marks that were equidistant from point P in order to start the construction of the perpendicular bisector. So a little bit tricky that one, but we got it done. Part B, the diagram shows a field LMN. A tree is to be planted in the field so that it is the same distance from the fences MN and ML, and the same distance from corner M as the corner N. Show by construction whether this can be done or cannot be done. Okay, and we've got a space to say if it is or isn't on the answer line. Right, first off, I'm going to make this same distance fences MN and ML. That's an angle bisector, and to do that I need to put the compass tip at M and draw 2 arcs that cross the 2 lines ML and MN. Okay, so you can see those 2 marks there. Then move your compass tip to each of those marks and draw another arc in between. and from the other one on ML. And you should find it forms a little cross which is between the two lines. Okay, and that is the direction that my angle bisector is going to go along. So from M through that cross, that should be the points that are equidistant away from ML and MN. Okay, now next we need the points that are the same distance away from the corners M and N. Now that is a perpendicular bisector. Now to draw a perpendicular bisector, just make sure that the aperture of your compass is like between half, a bit more than halfway between your points. I normally go for about 2/3. Okay, and then we're going to put the compass tip at N and draw an arc between them. Okay, and then coming back to M. It's the same construction from part A, isn't it? And we're going to draw another arc between them like that. So that's going to be my perpendicular bisector. Okay, so drawing a line through those two crosses and out the other side. Okay, so there we go. Now you can see that the two lines meet down here, and that is not in the field, is it? So the point that meets both rules is both the same distance from MN and ML, this point here, and also same distance from M and N. It lies outside the field. So I'm just going to write that down. Does not lie in the field. Oh no. So if it doesn't lie in the field, then it's not going to be possible then, is it, for this this tree to be planted in the field then under those conditions. Okay, so just at the bottom there in that space I need to write down this cannot be done. So it can't be done, can it? So I'm just going to write down in there this cannot be done. Question 8. A bag contains 35 balls. Each ball is either red or green. The ratio of red balls to green balls is 3:2. Work out the smallest number of balls of each colour that have to be added to the bag so that the ratio of red balls to green balls becomes 7:3. You must show your working. Okay, so we've been given the ratio to begin with. The ratio of red balls to green balls is 3:2, and we know the total number of balls in the bag. Okay, so we can do like a dividing by ratio method to work out how many red balls and green balls there were to start with. Now, if you want to divide by a ratio, you need to take the ratio itself, 3:2, add the two numbers together, because that tells you the number of shares there are altogether. So 3 plus 2 is equal to 5. So then what we want to do is we want to divide 35 by that number of shares, and that will tell us how many there are in each share. So 35 divided by 5 is 7. Okay, so that means that the ratio of red to green, which started off as being 3:2, if we scale that up by the number of balls in each share, which we worked out to be 7, then we should work out the number of red balls and green balls that there are. So 3 times 7 is 21, so there must be 21 red balls, and 2 times 7 is 14, so there must be 14 green balls. Always worth just double checking that those two numbers add up to your original number. They do. 21 plus 14 is 35, so I'm feeling confident I've done it right. Okay, so that's the number of balls that we're starting with. Now we need to work out the smallest number of balls of each colour that have to be added to the bag so that the ratio of red balls to green balls becomes 7:3. Okay, so now we need to take our 21 red balls and 14 green balls and add a few red and green ones to it so that the new ratio becomes 7:3 then, doesn't it? Okay, now obviously this number on the left, the red one, needs to be a multiple of 7 then, doesn't it? 21 is a multiple of 7 at the moment, but I don't think that's going to work out because the green one also needs to be a multiple of 3 and 14 isn't. Now if we added 1 to green, that would make green 15, but that doesn't help us because 3 goes into 15 5 times. So if we add 1 green, so if we add a green one in here and make 15 balls, that divides by 3. I'd have to divide it by 5, wouldn't I, to get 3? But I can't divide 21 by 5. But if I added a few more balls to it, maybe I could find a number of balls there that if I divided it by 5, I'd end up with 7 then. So 5 sevens are 35. So I guess if I added 14 in here, then that would give me 35 red balls and 15 green balls, which then, if you divide both sides by 5, is going to give you the required ratio of 7 to 3. I think that works. Okay, so the number of red balls added to the bag, I'd need to add 14 red balls, and the number of green balls added to the bag, well, I just added 1, didn't I? So altogether, we added 15 balls. I think that is the smallest way of doing it, because literally I only had to add 1 green ball to get 15. Any other multiple of 3, I've had to ended up adding more green balls, and therefore I'd have added up a lot more red balls. So that is definitely going to be the smallest addition. So yeah, feeling good about that answer. 14 and 1. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.